stronger tomorrow. Let's start to make a difference, teaching everyone to learn. Through science, health, and technology, we will share our expertise. By promoting knowledge and policies, we can build a better world. Let us take a stand for our visions alone, bringing future plans for the people to grow in a life filled with happiness and green. Here a symbiote, building the future is our legacy. We'll achieve our goals through partnership, creating opportunities. By working hand in hand, we can accomplish all our dreams. For a better quality of life is now within our reach. Let us take a stand for our visions alone, bringing future plans for the people to grow in a life filled with happiness.
Nandini. I will be the moderator for today's webinar. So before I introduce our speaker for today, so we have a message from our center director, Dr. Shah Jahan bin Asanakuti. So let us join together to listen to his speech before we move on to the next session of the seminar.
Bismillah ar-Rahman ar-Rahim. Dr. Khairah Muhammad Hanafia, the speaker of this webinar, the co-founder Malaysian Science Communication Network, Ms. Rasha bin Adi Osman, Deputy Director of Administration Division, Sima Rexham, Dr. Jayalakshmi Mutaya, Acting Director, Training and Research Division, Sima Rexham, Dr. Nantini Jairam, Science Education Specialist, Coordinator of the webinar, Science and Mathematics teachers from all over Malaysia and senior countries, as well as all Wrexham staff. Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh and pleasant afternoon. I am pleased to welcome all of you to the webinar on communication strategies for teaching science and mathematics to primary learners hosted by Senior Wrexham today. As we all know, this subject can be challenging for young students, but with the right communication strategies, we can make them more accessible and engaging. Effective communication allows the teacher to recruit more students to engage with science as well as to collaborate and learn about issues related to STEM application. This webinar is aimed to expose the primary school teachers to currently available techniques and activities to exchange information or viewpoints on scientific information with students by effective communication. Before moving on to our content today, please allow me to welcome Dr. Hairia or Dr. Kai from Malaysian Science Communication Network for taking your time despite your busy schedule and being here with us today. We appreciate your assistance and guidance provided to our people for educating the future generation. Ladies and gentlemen, the idea of this project is also to identify the current challenges faced by science and mathematics teachers in effectively communicating these subjects in primary school. This will enable Wrexham to design a comprehensive course for the science and mathematics teachers to master good science communication in near future. It is therefore to provide instruction on how to use academic language effectively, which includes encouraging students to read inclusive summary frames, helping students translate from academic to social language, and having students complete scripts of academic routines. I hope you'll be exposed with some basic idea on how to achieve this via this session. In conclusion, by using effective communication strategies, we can make science and mathematics more accessible and engaging for primary learners. Let us work together to create a positive learning environment where all students can thrive. On behalf of Senior Wrexham, I would like to thank all the participants for your support. We hope that you will have a constructive session, gain new knowledge and skills at the end of this webinar. Thank you.
Thank you so much, Dr. Shah. I think Dr. Shah has stated clearly the basic objective of this webinar for today. So now it's time for me to introduce our speaker for today. Dr. Kai is here with us. Hello, Dr. Kai.
Hello,
Thank you so
it's
much for
here.
Yeah, thank you so much for being with us today in your busy. I know you're very busy, and thank you so much for always responding all my messages and requests, and your willingness to participate with us to share your knowledge on this science communication and also maths communication for the primary school teachers. And let me share a few words about Dr. Kai before I hand over the floor to Dr. Kai. So, Dr. Kai Mohammed Anafi, who is also known as Dr. Kai, is also passionate about infectious disease and science communication. Dr. Kai is the co-founder of the Malaysian Science Communication Network and also an honorary fellow at Burnett Institute of Australia. She was awarded the prestigious award Endeavours Research Fellowship in 2017. She was the first female Asian champion of FameLab International in 2018 and recipient of the Ministry of Youth and Sports Malaysia Youth Award in 2019. Dr. Kai has trained many students and researchers at various stages of their career across the 20 over the 20 science communication workshops and educated science communication competition nationally and internationally. So a very warm welcome for Dr. Kai for today's webinar. And without further ado, and I'm passing the floor to Dr. Kai. Dr. Kai, the floor is all yours. And we also welcome the participants to ask any questions that related to our topic today throughout the webinar. And I will be passing the questions to Dr. Kai later. Dr. Kai.
Thank you so much, Dr. Nantini. It's been a pleasure working with you and Wrexham leading up to this event. And I'm so impressed at how many teachers are present today, even though I know how busy the teachers and schools are today. So I'm really honored. And I hope that in the short time that we have, I think we only want to spend a short time here, that you get some ideas about how we can use some communication strategies that I'm more familiar with, which is science communication. So just share quickly my screen and we can get started. And I also want to say how impressed I am that, it's not just people from Malaysia joining in. I can see people from the Philippines, Myanmar, Laos, even someone from Zambia. So
yeah. We have participants from all over the sea countries, and thank you so much for them actually for joining with us today.
Absolutely. Yeah. And so that's always great. And I hope there's something that everyone can take from this webinar. So the title of the webinar is Communication Strategies for Teaching Science and Mathematics to Primary Learners. But we kind of cheated a little bit. What we're talking about here, the strategies that we're talking about here is mostly science communication strategies. And this is because that's my thing. So as Dr. Nantini mentioned, I'm an honorary fellow at Burnett Institute. So my background is actually in the biomedical sciences. And I was a lecturer at University Science Malaysia, Penang for about 7 years. And I'm due to start another position at St. John Fisher University at the end of this year in microbiology. So that's my field of research and what I teach in. But really, the reason I'm here today talking to you is because of the fact that I won this competition called FameLab. And FameLab is this competition that was made to have researchers or academicians learn how to talk to the public audience. So not like they're talking at a conference, but like they're talking to maybe a 10-year-old or a neighbor. And so that made me realize how to change how I speak about science in order to get different people of all backgrounds be able to get something useful from what I'm talking about. And since then, I've been doing a lot of talks, also training workshops, and I became the lead author and editor for this training module called Science Communication and Practice, a Malaysian Perspective with Global Relevance, which is published by the Academy of Sciences Malaysia. And I also regularly write a column for the Star in Malaysia, the Star Malaysia called Science She Wrote. But all of this is mainly focused on how researchers or scientists talk to the public. So this is actually a new area for me as well, is to seeing how these strategies can also be... Yes? Sorry, is somebody talking? if you had any questions, happy to answer them. But if not, can you please mute yourselves just so that I don't think you're asking a question? Or you can put questions in the chat box and we can talk to them, talk about that later. So yes, so basically, what we're trying to do is to see what are some of the science communication strategies that we use for generally researchers and academicians to talk to a public audience, for teachers to use to talk to their students, and engage them better. So this is where we want to take the science communication strategies next. So before we go on, I'm hoping you can humor me a little bit. If you have your phones with you, you can easily just open the camera and scan the QR code. And that should take you to a website called menti.com. I'm sure some of you have used this before. Or you could go to the website menti.com and type in the code 34674509. And I just want you to click on the answer to the question, have you used science communication strategies to teach STEM? So I'll give you a couple of seconds to take that on. Maybe, Nandini, if you don't mind, maybe typing that also in the chat box in case people need to refer to it. And I can open actually, you don't need to do that. I can also just share the screen. I think it's this one. So this one. 1 second. Oh, no, sorry. While you're doing that. Okay, here we go. Now I can share it. Yeah. All right. Okay, great. I see people aren't having trouble doing this. So those of you who've just joined us, we're just doing a quick poll to see if the people who are joining us today have ever used science communication strategies to teach STEM. So STEM here is quite a broad term. Obviously, if you're teaching science as a general subject, or mathematics as a general subject, or maybe you teach biology or any special science subjects, or maybe a broad research subject at whatever level. Let me know if you've ever used science communication strategies to teach STEM. So
Yeah.
I'm seeing people, yeah, great. There's so already about half of the audience have been able to.
Dr. Kai?
Yes?
Yeah, maybe some of the participants, we do have participants from maths background as well. So maybe they feel when they see the sign communication words, so they get, confused. But I believe that, as you said, that science communication is basically the strategy that can be applied for all the subjects, right?
Absolutely. So basically just any of the communication
Yeah.
strategies. So we'll talk about this a bit more in a bit, but just take the question at face value. Do you think you've ever used it to teach any subject that falls under
Yes.
the umbrella of STEM? So that could be
Yes.
science, math, calculus, maths, modern maths, whatever.
Yeah.
So we'll just give it a couple more seconds. I'm seeing a nice trend here. There are a
Yeah.
lot of people who certainly try, which is wonderful.
Mm.
And the second group being people who haven't, but they want to. And of course, we'll have people who don't really know what that means, and that's perfectly valid as well. And that's what we're going to talk about a little bit as well in a little bit. And I see some it's amazing that there are 11 people who do it all the time, because it is a challenge. It's not easy. It takes a lot of effort. And so kudos to you. But really kudos to everyone, because what I'm glad I haven't seen so far is none of you think that you don't have time for it. Even though it is also a valid reason, there is a lot of things that will eat up into each sentence. So I'll let the poll keep going, but I think we've got a great spread here. That's really helpful for me to know that there's some use in me explaining a little bit about science communication, because, sometimes I assume people know, but if they don't, then, we'll be starting at a not so great place. Okay, so we've done the poll, and thank you so much for giving me that little bit of insight. Now I understand who I'm talking to a little bit better. So mostly people who want to use science communication. Maybe some people are not sure what it is. And a lot of people who have tried, maybe to whatever interpretation that they have of what science communication is. So that's great. Oops. So now I want to shift gears a little bit and start with a little story that I read recently, which was really inspiring to me. And it's about a teacher's role and experience in helping students become scientists or helping them learn to discover things. So the story starts with a group of students, so young students, probably first grade, second grade students, and they've been taken out to the garden. And what they see on the ground is a lot of these pods. I don't know if we have these type of pods in Malaysia, but they're quite common where I'm living right now in New York. So they're just pods with a lot of gum seeds in it. And they've fallen on the ground. And so one of the little boys picks it up and he shakes it and he knows there's something inside. So he goes to his teacher and he's basically asking her to tell him what it is and maybe help him out. But she doesn't. She just basically tells him, or it encourages him to explore. So he tries really hard, and eventually he's able to crack it open. And what he sees inside the shells are the seeds lined up in the pod. And this is the first time he's seen it. And this is the first time he's ever opened it by himself. And so he's really, really excited. And the teacher can see how excited he is at being able to do this. And she asks him what it is. And he says to her, it's secrets. So he's now called the seeds secrets, and that gives it something very special to him. And so all the children sees that he's found some secrets in these pods, and they've gotten excited, and they also start trying to open the pods to get their own secrets as well. And after the teacher has allowed them to keep exploring and feeling and opening the pods themselves, she then asks them, do you want to learn more about your secrets? Do you want to learn more about your seeds? Would you like to be scientists? And so what I think was amazing about this is that it didn't start with an explanation of what all the seeds are or what the pods are. What happened first was that the children were allowed to become curious, to unveil a mystery, and then they're guided to learn more about it. And I think that's the beauty of communication, is being able to use language and words, as well as, your nonverbal communication as well, to encourage, especially young learners, to be excited and to want to learn more. Because, we know science and maths are typically difficult subjects. And why would you do something difficult? Unless you feel like there's something valuable, there's something you can get at the end of the day, something that's meaningful to you. So this is basically the intersection of where science and math as a subject, as well as the art of communication, overlaps, and it creates wonder. I mean, there are so many people, many scientists, my colleagues, who have dedicated years of their lives to learn about very, very tiny proteins that some people don't even know exist. But it's because they've found their passion and they found something that gives them meaning. And so for primary learners or for young learners, they're not there yet. They really need to be encouraged to develop that interest and that wonder first. And so your mission, or basically our mission as educators to young learners, and this includes to our own children as well, is to spark curiosity and wonder first. And so I would like to convince you in the next, let's see how many minutes we have, 20 minutes, 22 minutes, that you can use science communication as one of those tools to spark this curiosity and wonder. And I'm not going to teach you, or I can't teach you how to teach. That's your expertise. As you saw earlier, I've only taught university students, And I haven't even been doing it for very long. So my area or my experience that I can share with you is going to be focused on science communication, whereas what you have is the pedagogy and all the subject expertise, and you
Yes.
know what kind of learning experience to create for them. And what I'm going to share with you are some maybe strategies or tips on how to communicate when you're facilitating these learning experiences. And ideally, when these two come together, we will have more effective STEM communication. But you're probably wondering, and I'm definitely the number of the teachers present who said, I'm not even sure what this means, science communication. So let's have a quick look about what this is. What is actually science communication? There are a lot of definitions, so you can Google it and see different people say different things, different people using it in different ways. But for me, it's really simply about the sender and the recipient for a science-related message. So the science-related message could be the topic of a research. It could be a communications piece for a health ministry. It could be a topic in a textbook for a particular subject. So anything that's a little bit technical and complicated could be basically a science. So it's not just science, really. It could also be math. It could also be architecture. It could be finance. When it comes to the person receiving, viewing the topic or the content as being more technical and difficult at the surface, then it becomes something that is a barrier for them. And so science communication is supposed to help us overcome that barrier a little bit when we think about who the recipient of our message is. So usually when, let's say that we're talking about actually science, right? So in research, so that the science can be any discipline really, but we have the sender being the subject matter expert. So for example, a mathematician, and the person receiving the message for this content is also a mathematician. This is when the communication is very different from when we talk about science communication in general. So when an expert is talking to an expert, one, they usually speak the same language already. And so the purpose of their communication is also a little bit different. When they're communicating, often they're trying to build on each other's work. To them, the details is the depth is very important because that's what's going to help them improve each other's work. So it's different when, say, the subject matter expert, let's say a scientist or a genetic engineer, wants to talk to a recipient who is a mathematician. So that person is now not the subject matter expert for the topic genetics. And so you can't expect them to be able to use the information that's very in-depth or detailed, spoken in very technical language, the same way another genetic engineer could. And so the purpose now has to be different. The purpose of communicating from a subject matter expert to a non-subject matter expert has to be more about what is useful for this person, what is meaningful for this person, and what can they actually understand. Or sometimes it could also be what can they use for their field, without really necessarily understanding the full details. So in brief, science communication is about understanding who you're talking to and changing how you talk to the person, even though you have the content being, let's say, a science or a technical content.
Dr. Kai?
Yes.
So basically, your message is that we need to profile our audience before we start to communicate the message to them, right?
Absolutely. So this is the next part of it. So that segues
We
into
have, sorry, Dr. Kai, we have a question here from Mr. Dennis from Zambia. So his question is that he have stated the challenge I find with these strategies for most our teachers here in Zambia is that most classes are very large. So are you able to share some thoughts on how to implement the same in a large class setting? So that was his concern actually. Maybe you can share that later, Dr. Kai?
Yes, I'll keep that in mind. So I'll definitely point that out. It is always a challenge to have a big class. when I was teaching undergraduate classes, we had the students up to 150 people in a lecture. It's really hard to fully engage with everybody. But I think what we're talking about here is to first think about the audience in a broad way. As in, if you had a majority group that you can think about sitting in that room, that's who we think about first. So who is our audience? And in this case, because of this session being for primary learners, or let's say our audience is mainly primary learners of science and maths. So the first question we ask is, why are they here? So that's an easy one, because they have to, right? They have to go to school, they have to sit in class, they don't have an option so much. So in a way, that's already good for you because you have a captive audience. They're stuck. So it's not as challenging, say, as an audience that can decide to just drop off the call like I have right now. So that's a more challenging audience to capture. But even though they're captive in body, they're not really captive in mind or spirit, right? You could still lose them to a daydream. So knowing why they're here is first the important thing that we need to figure out. And I think this goes back to also children understanding the value of education, which is always going to be a bit hard, right? Because they just want to have fun. They don't want to sit around. But so we'll get into that a little bit later. But the other question that we would ask about the audience is, what do they know? And so I think this is where I hear that there's a bit of a challenge as well, where sometimes the teacher expects the student to have a certain basic understanding of a subject from a previous year or a previous class, and they realize that some of these foundations are missing, and that becomes a challenge for the teacher to move forward. So understanding what the students know is also critical for you to be able to keep, building on what they know. But then there's also what they think they know. So, sometimes you have kids who think they're very smart, and so they may have gotten some information somewhere that may not be as accurate, but they think that's correct already. So that's already something that's going to influence how they receive what you tell them as well. So this is some of the things that might happen with your audience. And then the final three, I think, is what we can try and address. What do they want to hear? What do they care about? And what will they respond to? Because, children can be different. Of course, no two children are the same. I have two boys. They're very similar in some ways, but they're very, very different in other ways. But they have some common things that help me figure out what they might enjoy, what typically upsets them or what makes them a bit happier. And so, of course, your audience is larger than n equals 2. So it's going to be, you won't be able to address everybody, but just having a thought about my class, who's actually in that room, who's sitting down and listening to me as an audience. Do they really want to know about these things? Or would they rather learn about something else? So just understanding where they're coming from is going to be the first step towards getting to meet them halfway and getting them to meet you halfway so that you can have a better experience. So, because at the end of the day, when it comes to science communication, it's not about what you say, it's what they hear. Because as we all know, you can keep talking all day long, but what they leave at the end of the day with is really what they find appealing or useful or meaningful to them. And that's assuming they don't get examined on it, right? Some people will study for the exam and then forget the year later, but that's because they haven't internalized it, and it's not what they want to hear. So the first step in science communication before you communicate with your class is to put yourself in their shoes. And you may be wearing these type of shoes, and you may be wearing these type of shoes, but if they're wearing these type of shoes, or I think I had another pair of shoes before, but if they're wearing these smaller shoes, and they have a different lived experience. And so that's just something that we want to keep in mind. And I'm sure you have plenty of children that you know well, that you can learn from as well. And there's a reasonable chance that you can extrapolate some of that to the audience that you have if they're in a similar age group. So we're going to do a quick profiling exercise. And if anybody wants to unmute or put in the chat box, you can let me know who you think the group labeled A wants to drink. Not who, what the group labeled A wants to drink. Does anybody want to unmute or let me see?
Boba tea.
Boba tea. Yeah, thank
Oh,
you.
boba.
Boba tea. I guessed that as well. So we're thinking alike. What about the couple labeled B with the big blender and the fruits?
A tea.
Which one?
The
The
green
green.
water.
The green water.
The smoothie one.
The
The green
smoothie.
Green vegetable drink.
The green
Hello.
vegetable drink. Yeah, I think so. I mean, you can only get that using a blender. So I think that's a very smart guess. I guess that too. How about the lovely people in group C?
The last picture,
tea.
maybe the
Tea.
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 Yeah.
Hot
Yeah, we're all agreeing here what they want, which is great. Like
Tea.
nobody's
Hot tea.
dissented
Black
yet.
tea.
Tea, awesome. And what about the last group? Our primary.
of course, milk tea.
Tea.
McDonald.
Milk.
Isn't that amazing? Like, I don't know any of you personally, you don't know me, but we're all thinking alike here. We're looking at these people and we're guessing what kind of drink they want. And in doing that, we're actually profiling them as an audience, and the subject here is drink. What drink do they want? But we're thinking about how these drinks taste, what cultural preferences might be going on here, what are some current trends, especially for young people. Trend is very, very important. We're also thinking about nutritional needs for some people, right? Because they prioritize health, or physical needs, or maybe even religious or belief-based needs. And we look at them and we already know what they're more likely to want. Now, of course, these are stereotypes, so stereotyping can be dangerous because there are some children who love tea. There are some, more golden citizens who love boba tea as well. But if you want to basically have a quick and shortcut way, especially for an audience that's quite big, you can aim for the majority, and I think you'll still get somewhere. You won't miss it entirely. So well done. You've already done an audience profile, but this is for drinks, which is a little bit easier for us. But that's basically a step in what we want to be doing, right? To be thinking more about who we want to serve or who we want to offer these things to. So in this case, what we want to offer is either science or math content. And so I want to share very quickly, I hope we have time, yes. If not the whole video, then some part of the video. Maybe some of you have seen this. If you have, and I hope it's a great refresher to those of you who haven't, it's really wonderful to see how communication can change when you're talking to different audiences. So I'm going to stop sharing here and open my other screen. And hopefully you guys can hear sorry, 1 second. Ooh, there we go. All right, let's try it again. This one. All right. Let me know if, no, it's not the video. Okay, that's better. Screen share. Sorry.
Yeah.
1 second. I want to open the video. Okay. Right, now this should work. Okay. All right. Can you see the screen? There's a young
Yes,
man.
Dr. Kai.
Glasses. All right.
My name is Neville Sanjana. I'm a biologist at New York University and the New York Genome Center, and I've been challenged today to teach one concept in 5 levels of increasing complexity. My topic is CRISPR. CRISPR is a new area of biomedical science that enables gene editing, and it's helping us understand the genetic basis of many diseases like autism or cancer. I think today everyone can leave with understanding something about CRISPR at some level. Hey Tegan, do you know what we're here to talk about today?
Science.
We are here to talk about science. We're here to talk about something called CRISPR. Have you heard of that?
No.
CRISPR is a tool that scientists are using to edit or change genomes. Do you know what a genome is?
No.
It's kind of like an instruction manual. The instruction manual that makes you who you are. Sometimes there's mistakes in the instruction manual, like people get sick.
Like allergies?
Like allergies. Do you have friends at school that have allergies?
Well, I have allergies to penicillin and azithromycin. They're a type of medicine.
It's good that you actually know exactly what you're allergic to. For people that have really severe allergies, we could erase where in that big instruction manual where they have those allergies and maybe make it so that they don't have those allergies anymore.
Blowing my mind.
Do you know what CRISPR is?
Absolutely not.
No,
No,
okay.
not at all.
CRISPR is a way to edit the genome. Do you know what a genome is?
Yeah, it's the DNA.
DNA is kind of the language that the genome is written in. And the genome itself is an instruction manual. It describes how to make you, how tall you should be, what color hair you have, or what color eyes you have. So what CRISPR is, and an easy way to think about it, it's like a molecular pair of scissors that can go through that long, long genome and find specific places, make small cuts, and edit it. What do you think about being able to edit genomes?
It's actually kind of cool because then you could change, can't you technically change things about a person if you edit the DNA?
Sure. So how do we determine what's the right uses then?
I don't think it should be used for almost cosmetology reasons
Okay.
or like for people just to be like, oh, I want to be 5'6" instead of 5'4", or like reasons that aren't necessarily the most important. I just think if it could genuinely help someone, like if someone had cancer and there was a way to fix it or like slow down the growth.
So a lot of the work that we do in my lab is about being engineers of DNA. We try and look to see what mutations cause diseases and to see if when we change those mutations, if we can take a sick cell or organism and make it healthy again. Do you know how CRISPR works?
So it works where you have this CRISPR, this Cas9 complex and
Protein, Cas9 protein?
Cas9 protein complex, along with something called a guide RNA.
That's right, that's right.
And that RNA will basically tell this protein where to go and what gene to sort of cut out. From what I've heard, they're like close to almost curing muscular dystrophy with it. But there's a lot of, I guess, ethical issues that come up with it too.
One of the really nice things actually about CRISPR is that we can use it in human cells. You know, if you ask most people, should you use it to cure cancer? Most people would say, yeah, those are good uses. But there are other areas that are a little bit more problematic, like editing the germline, which means something that could be passed on. So I think a lot of people are concerned maybe that CRISPR will be used in kind of frivolous ways, maybe just to choose somebody's eye color or how tall they are, or what color hair they have. And I think what a lot of people don't realize maybe is that the state of genetics is not quite there.
It's nice to think that I can go in and choose exactly what eye color I want, but fundamentally, science doesn't exactly know all of that yet. We don't know every single gene related to eye color, nor the regulatory mechanisms, nor the epigenetics. This is a huge,
right. So we can use CRISPR
issue
now to try and understand better how do our genes relate to these different features, these different phenotypes that we have. There's a lot of work left to do before we even know I think what are the knobs and dials? What are the controls that affect eye color or how tall you are? So I think this question right now, even though it's important to discuss, I kind of feel like it's more theoretical right now.
Yeah, or is it really even a point necessary for conversation? Because people are going out every single day and getting plastic surgery to change how they look. How is this any different?
So Matt, what are you doing right now in the lab and how are you using gene editing in your own work?
Right now, one of the questions I've been very much interested in is trying to understand the effect of human genetic variation on using CRISPR-Cas9 reagents. because you and I, just sitting here, differ in millions of different locations within our genome. We use these guide RNAs, which are 20 base pairs, and we match it to different places in the genome. But what if there's a mutation at that site? And how does that affect?
A mutation that's different between you and me. It's the same site, but there's a slight difference in the DNA between you and me.
Exactly. Let's say in you, it's a perfect match, and in me, there's one that's actually a mismatch. And how does that affect things in the lab? Because maybe it won't be as efficient. It won't be able to bring Cas9 to the correct site and cut there.
So when people are using CRISPR now in the lab, are they really sequencing the exact cell type they use, reading out the genome of that cell before they use CRISPR?
Not many do that. It would ultimately be the best way to do it, for sure, because the reference genome that was published in 2001 was kind of just one person's genome.
All right, so we've had a 5-minute journey of the same person talking about the same thing, but to different people. So I'm going to go back to the slides just now. I know some people are having some issues with the video and all, so I apologize that you may not be getting what I wanted to share as much, but hopefully you can still benefit from this session. And I hope some of you actually did get to see most of what I showed. So we saw this Neville Sanjana, who's a biologist, and he spoke to first a 7-year-old, and then a 14-year-old, and then an undergrad student, then a grad student, and then somebody who's actually doing the research in CRISPR, this technology that I hope some of you now know because of the great explanation that he gave. But what I want to ask you to think about is, what did you notice were differences in how Neville Sanjana explained CRISPR to different people? What did you notice about his facial expressions when he was talking to different people? Maybe the choice of words he used, any hand gestures that he used when he was talking to them, and types of questions that he asked the different people. And then what were the similarities? I think we have a bit of time. Does anybody want to just unmute and tell me what they think? One obvious thing that they saw was maybe different, and then maybe another person can volunteer what they thought was similar. Or you can write it in the chat as well. So let's type of questions, right? In the type of questions that he asked, we noticed that, right, so Jemima, that's absolutely right. So some of the words he was using was quite different when he was talking to the 7-year-old, and the way he responded to their questions was also different. And what I noticed as well, when he was talking to the 7-year-old, what was it, Tegan, he was a lot more animated, a lot more facial expressions, and the detail that he gives to the answers when they ask him questions was also less. And what I hope you notice, yes, the expression, absolutely, like very from very animated, a lot more gestures, different body language, a lot more encouraging, a lot more like, I want you to feel comfortable with me. Whereas when he was talking to the others, he was a lot more cool, right? Because he's like, they know what I'm talking about, and they understand the depth of the information that I'm saying. And in fact, some of the things, those people were actually giving him an education in a way. So it's a lot about, this is how we see the shift between talking to a public audience or an audience that is a non-expert, all the way to talking to an audience that is an expert. And as you can see, where on talking to the audience that's a non-expert, the main purpose was he wants them to know what CRISPR is, how it works, roughly, as well as what are some of the ethical issues, what are some of the applications, right? And then at the higher level, it was more about actually exchanging what's the problems in the field, what are some of the other issues besides the ethics. And ethics were some of the main constant themes that he talked about with all 5 people. But there's some different nuances or different aspects of ethics that he was talking about. But I hope what you realize as well, what was similar throughout all of them, thank you so much to all of you who pitched in to discuss. What was similar was that at the end of the day, all of them were talking about CRISPR, how it works, and what are some of the ethical issues, or what are some of the challenges or the problems. It's just differing in the level of detail, the type of jargon or the type of language that's used. And so this is where we're seeing how science communication can be really useful to remove barriers from people understanding really complicated things, without really diluting the value of the information. Because at the end of the day, it's only useful if it means something to the audience, right? So that's what we want to focus on. So who again are our audience? So who are our primary learners? And I'm sure you have your own data and your insights of your students. In general, what seems to be a common thing about children aged 7 to 12 years is that they are more relational. They want to make friends. They enjoy group activities. Peers are very important to them. They're also quite conscious about, things that are changing about themselves and any differences as well in appearance. They also have a very strong desire to be correct. They don't like being wrong. I mean, nobody likes being wrong, but they really take it to heart. It's very difficult for younger children to be told that they're wrong. And they want to be treated fairly. Like justice is a very strong concept. Like every other day I'll hear my son go, "It's not fair," because I've done something he thinks isn't fair. So fairness is very important to them. They want to fit in and they want to be cool. So those are things that are important to them. And as you all may know, they can be very impatient, very anxious, cannot sit still. And, you can say the wrong thing and they become discouraged. And so that's also a very delicate thing to handle. But I think the wonderful part is this age of children, this is when they learn and they can really be sparked to love something. They can be joyful, enthusiastic, and they can be really, really fun to work with once you manage to tap them the right way. So some quick science communication tips before I let you go. Because obviously we don't have that much time and I wish this could be like even more interactive, but I'm sure some of you have already done this, but a really cool science communication thing to do is to ask open-ended questions. So what that means is to occasionally ask questions that don't have just one right or wrong answer. So of course you can ask closed-ended questions when you want to check for understanding, but when you want to have meaning associated to the learning, you want them to think a bit more. So questions like, why do you think different plants use different seed dispersal mechanisms? Or what are some ways we use fractions in daily life? So that lets them internalize a bit more. It also stimulates their language. It challenges them to think independently and critically. And I think the most important thing about asking open-ended questions is the children who tend to be afraid of being wrong are less afraid because they're like, well, it's not just one right answer. So there's a higher chance that I might be giving the right answer. And so they're more likely to also want to respond. And I think that's already a great win if you get students to think about the answers, whether or not they actually voice it out. The other tip is to encourage questions. And it sounds really obvious, right? Like I'll give a lecture and at the end of the lecture, I'll be like, does anybody have any questions? And then it's crickets, 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 right? Apparently saying, does anybody have any questions is a great way to have people not ask questions. Yeah, so I think the idea is to actually create an environment where asking questions is normal. Asking questions is a safe thing to do, that there's no such thing as a dumb question, that it's not a sign of weakness, but a sign of interest. And also really, really appreciate when people ask questions, because then that encourages other people to ask questions. So not even if the question you think is like, why are they asking this? This isn't related to the topic. So refrain from saying that. Still point out that, I'm glad you asked, because the act of asking is already, I think, an important thing that they're showing some interest. Or, say, interesting point. Let's think about this. Does anybody else have an idea about what this question that this student has asked? Another thing that's really cool that we could do is actually allow students to practice thinking up questions in assignments. So let them think about the material a bit more, so that next time questions come easily to them. And also, I wish we could do this more for this session as well, is to actually allocate a proper time for questions. So ideally, it's not just left towards the end, but I think we did that a little bit, right? As questions came in, we tried to address them. So there is room for questions, and that's encouraged. The other science communication tip that I would give is to use declarative language. So I'm sure many of you know what this is already, but if you don't, it's basically the type of words that we use so that we're not giving somebody an instruction. We're giving them information and we're asking them to think about it. So, for example, if the class is very noisy and people are walking around, or let's say a lot of people have forgotten to mute their mics, I can say something. It's very noisy when people don't mute their mics because I get distracted. Or if you say to the class, everybody walking around and being noisy makes it difficult for me to teach. And so they can think about what that means rather than saying, everybody sit down and be quiet. And so that's a different type of language. It's called imperative language. So that might be useful sometimes, but occasionally using declarative language is a good way to actually promote independent thinking and is also more encouraging and less judgmental, especially to kids. This one I really try to use in my class when I can, at least once in a topic, which is to use some kind of story or analogies. The story could be directly related to the subject matter, or it could be a side story. So an analogy that I really like to use, because when I teach immunology, is this idea of the human cells, the immune cells being like the armed forces. So all the different cells have their own, uniforms, they have badges, they have different ways to recognize each other. And when they're fighting the other side, they use different weapons. And these analogies tend to become more easy for students to imagine something. And once they can understand the concept, then they can start committing to memory some of the details that actually scientific details. So I would say when you're trying to do stories or analogies, you can't do it for everything, but if you can find some main ideas or concepts that are really important for students to try and learn, that's the one you want to try to make as attractive as possible. And once the interest in the main idea is there, then you can start feeding them or getting them to work a bit more at understanding the details of the topic. And then the other tip is to take advantage of media resources. So I think one of the earlier questions is about what do you do about a large class, right? So I think you can have as big an audience as ever for any video. And so some good media resources are a good way to still get a lot of people to interact with the content, because good media resources actually hack into a lot of pathways. So they're very visual, they have good audio, they sometimes also stimulate emotion, they can have some humor. And so these are all more engaging in general. And it removes the pressure from you to actually engage individual students because they're kind of engaging with the content that you're sharing. And I want to share very quickly this tool. If you haven't heard of it yet, you might want to have a look at it later. It's called Edpuzzle. So of course, this relies on you being able to use some kind of online platforms with your class. But if you could, it's a free tool, I think, for some basic accounts. But what it lets you do is you can create assignments based on a video. So my colleague from the Malaysian Science Communication Network, Mateen, he made this video assignment on the topic, the most radioactive places on Earth. And he's able to decide at which point of the video pauses and a question pops up. So when the question pops up, the student has to answer the question and then they can move on. And they can't just skip the video, so they need to also watch the whole thing. And he can include multiple choice questions or single answer questions or even open-ended questions to ask for opinions and thoughts. And this is a great way to engage a lot of students simultaneously, basically. So this is an example of one of the questions, multiple choice questions that he had for this assignment. And there's a lot of different things that you can do with this type of video resource. And they're a great tool to really, like as a shortcut, communicate with your students. So last couple of slides. Obviously, not all of us are going to be like, public speakers or public presenters when we're teaching in our class. I mean, when I teach in my lectures, at least 3 or 4 people fall asleep. But I think what the goal is here to ensure that we're trying our best to create a good atmosphere for learning. So this is things like having a healthy posture when listening. Let's say if a student is actually responding or asking us questions, giving them room to actually process what you're showing. So not rushing through the content that we're sharing, having them giving pauses to the content so that they can actually digest the information. And similarly, not just having information, but including as well some challenge to the information. So like giving them a chance to think and interact with the material during the delivery. So making it a bit more interactive is something that's good communication style as well. All right, so that's basically all for me. Just basically, if you leave this webinar, I hope you remember 2 things. It's just that you need to start thinking about your students as a specific audience, and you're already halfway there to be doing science communication. And they're a specific audience that needs to be captivated, challenged, and encouraged. And finally, to use different resources or tools. Media is a great one to help interact with as many students as possible to reinforce the learning. So that's all from me. Sorry, I think I went a little bit over time from what I wanted. But thank you all for listening, and thank you to all the teachers, because, I mean, what would we do without you? So I hope some of this has been useful. I'm going to pass it back over to Dr. Nandini.
Yeah, thank you so much, Dr. Kai. And we have one question here from Chegu Fatlin Zahira. The question is, what strategies can teachers apply when teaching science using second language to teach the content of science?
Yeah, that's a great question, teacher Fadlin. To be honest, I think that's always been a struggle for a lot of us here in the Southeast Asian countries. English is not the first language, but a lot of our science and maths references or content are typically English based, right? So I think this is where, and of course, it depends on whether or not you have the facilities to create these learning experience, but there are ways to learn so that you can rely more on sensory experience rather than just you explaining something. So if explaining is the challenge, as in the language that you use to explain it, having basically like Play-Doh or Legos to demonstrate how things work for a particular subject. That's not only one way to overcome the language barrier, but it also is sort of a psychomotor opportunity for students to learn as well. But it's a really hard question, and I don't have a clear answer for that. I hope Dr. Nandini, once she's done working on her module for primary learners, will have some better advice on that. But yeah, I think it's basically coming up with more creative modes of learning. So there's obviously the auditory modes, visual modes, comics, for example, that they don't need a lot of description, but there's images. So that sometimes helps as well, as people understand without relying on comprehension of the language. So thank you for that question.
Thank you, Dr. Kai. And there is a lot of requesting for your slides, if it's possible. So,
So this is recorded, I think.
Yeah, this is recorded also. Yeah, we can share the recorded session later with the participants as well. And thank you very much, Dr. Kai. I think within the very short time, you have really given a very good insight about what is science communication and what is basically how they can apply this to any of the subjects actually. But I'm sure there is more than that we can share with our teachers here for better reach of science and the mathematics subject as well. So as a first step for that, Praxam is in plan to develop a specified module, especially for primary school teachers focusing on the science communication. And the aim of the module is to how we can actually share in detail of how to communicate, maybe with more examples and so on. And thank you so much to Dr. Kai for willing to help us and guide us on this developing module as well for this. So here we can see that our research officer is sharing a form. That basically the information of the form information will be used to develop a more specific module according to the need of the teachers who have participated the webinar. And upon the completion of the forms, we will be emailing the e-certificate to the participants later. And once again, thank you to all the teachers from all over the C countries to join the webinar for today. And we have really received a very good response for the webinar actually. And once again, thank you so much, Dr. Kai. And before we end the seminar session, I would like to kindly request all the participants to turn on the video for a group session, group photo today. Kindly please turn off your video, please.
去哪里看啊？
Yeah, I think our ICT team is ready there for our video session, photo session. Okay.
去哪里看留言？哪里看？
1,
人家给
2, 3.
人家给那个人家
Okay, with that, so we have come to the end of the webinar. So please help us to fill the questionnaires, and thank you so much for Dr. Kai and for everyone to join the webinar session today. Bye-bye. Have a good day.
Thank you very much.
Thank you, everybody. You're a great audience.
Thank you so much.
Thank you.
Dr. Kai and Dr. Nandini.
Thank you.
Thank you for the meeting. Very informative.
Thank you for the meeting today. I'm from Cambodia.
Thank you for the meeting too. Thank you so much, Senior Exam.
God bless po
Thank
from
you, Rexam.
Philippines.
Thank you for the fruitful